NPO was initially established by the famous Chinese engineer Ko Zhentianyu. Maybe a lot of people can really recall that because he was the famous engineer who actually built the first railroad in China. Okay. So yeah, that's the timeline for our whole organization. So the first CIE was founded in Cornell University in 1917. And then later on, the Greater New York chapter was established. And then it's our San Francisco Bay Area. And then we have other three chapters, which is Seattle, Dallas, Fort Worth, New Mexico, Albuquerque, and LA, which is Southern California location. Okay, we are like occasionally holding a lot of events, and then we have a strong collaboration with local like other organization as well. Yeah, like last time we have cooperated with the semiconductor organization to hold an event on the semiconductor topics. So yeah, if you are interested in all the events we're hosting in the near future, welcome to go our official website so that you can find more information. And then our mission is to promote technology advancement, networking, and communication among engineers and scientists to promote the well-being of engineering community. So in short, we're the nonprofit organization helping engineers, scientists, professionals in this community. And then here are the highlights for the past events. And also we want to specifically mention the Nvidia CEO, Jensen Huang. Like last month, we were invited to the events, which we got a chance to have a dinner and talk the recent topics with Jensen. So it's really excited. And during the COVID time, we have all the virtual events as well. And then this is our annual conference. And then we have annual conference every year. And then we have like a large conference this year happened in New York. And next year, we will have the annual conference in Seattle. And then here are all the highlights with all our potential partners and potential collaborators located in Bay Area as well. Yeah, so I mentioned that we have a lot of volunteers, cross-culture events, and then we promote to help the engineers, professional scientists in this community. And then fun fact, actually Boeing's first engineer was actually from CIE, our organization. So we do have a lot of outstanding engineers are coming from CIE. And then we're not only have like technical groups, but we have other specific groups as well. Like for instance, emerging technology group, which is part of Dr. Williams. We are occasionally holding a lot of interesting topics, like for instance, in artificial intelligence and different topics in artificial intelligence and other topics as well. And then we have the largest technical group, which is electrical engineering and computer science. That's where our like major board member are coming from. And then we have electrical design, biomedical, and young CIE. For young CIE, it's more like volunteering, having fun, having opportunity to mingle with other professionals as well. Then last but not least is subscribe our newsletter and subscribe all our social media account. Then yeah, so that you can have access to the past events, recording for the past events, including tonight's events. We post every single seminar onto our YouTube channel, so you're welcome to check our YouTube channel, and also all the other social medias, because we post every single events information on all the social media channels. And then let's welcome our tonight's other speaker, Dr. William Cao. And then I want to give a couple of highlights before Dr. William Cao actually give his speech. So Dr. William Cao has more than 40 years technical experience in his specialty, which is engineering, electrical engineering. And then he has been the adjunct professor at UCLA. Electrical engineering department, has been the senior member of IEEE, and then currently teaching clean technology and emerging technology courses at University of California, Santa Cruz, which is very close by. And then he has been giving like more than 90 seminars in the past 10 years, which is pretty awesome. And then we have all the listed interesting topics that Dr. William Cao has been specialized in. And then Dr. Cao is not only the technology watcher, but also the learner and also teacher as well. So now let's give a warm applause to Dr. William Cao.
So we can go to my.
Yeah.
Okay.
Let me. Yeah, can you close this one? That's really
the first slide.
And then show it.
Okay.
Let me see what it is. I'm sharing.
Okay, thank you.
Oh, yeah. Let me, why doesn't give me the Zoom link?
Okay, thank you, Christina. Hopefully everybody can see the slides. I still have the thing. Do you want to just downsize it? Okay. Thank you. Good evening and welcome to the seminar this evening. Really appreciate everybody, braving the bad weather and coming to listen to my talk. So this evening's talk is going to be on AI chips. For the past 2 or 3 seminars, all my topics have been on AI. Last time was on new AI technologies. Tonight, I'm going to shifting a little bit more toward the hardware side, talk a little bit about AI chips. Okay, so tonight's talk is going to be AI chips and overview. So if you don't know anything about AI chips, don't worry. Hopefully by the time you leave this seminar, you'll be dangerous enough to, that you know enough about AI chips. Okay, so this is the agenda for tonight's talk. I'm going to give an overview of the whole subject. So basically, usually when I give a topic, a seminar, I cover the 9 yards. So usually you start by saying, what is the topic? Why do we need it? Why do we talk about it? How does it work? Okay, who is involved and so on. So basically, what they call the 5 W's and the 1 H, right? Okay, so we'll give a talk about, we'll discuss about what are AI chips, why do we need AI chips, how do the AI chips work. We'll talk about various kinds of AI chips. The ones that are most well known are the GPUs from Nvidia, the graphics processing units, but there are a lot of variants. Okay, so we have also the originally when all started with the Intel CPU, right? And now there's a thing called DPU, which is data processing unit. There's NPU, which is a neural processing unit. Neural because AI is imitation of the biological way that our brain works. So it's after neurons. And then TPU, which stands for tensor processing units. There are basically 3 major categories. One is the GPUs, the ASICs, and the FPGAs. So everybody who is in semiconductors probably are pretty familiar with all these 3 types of semiconductors. We'll focus about the two main applications of AI, which is training and inference. So basically, in order to do AI, you first have to create a model. You have to train the model. And then after the model is created, then you infer, you make use of it. Okay, so that's inference. The other thing that distinguishes which chips you select is that depending where you are cloud-based or edge-based. Okay, I guess everybody is familiar with the cloud. That's where all the servers and the large computing power and memory resides. But right now, most recently, the emphasis has been shifting toward edge because you have to be able to react real time. For example, driving, okay? So driverless cars, you need to be able to stop instantly, right? So you need to be able to have the compute power and the memory at the edge, which is where the device is. So given all these complicated scenarios, how do you go about selecting the right AI chip? Because there are many kinds of AI chips that will be presented this evening. We'll also go over the market, the AI chip market. Okay, so all the well-known companies, I'll go over each of the major players as well as their products. Okay, and then we'll wrap up with the summary and conclusion. So that's basically the agenda for tonight. So let's talk about, give a quick introduction for why we are talking about AI chips. So for the past 7 to 10 years, I guess AI has been labeled as an emerging technology. But up to now, most of the people involved were the experts or the people doing research. And there's, of course, people working at Google, at Alphabet, and Apple, and so on. They're also working on it. But for the typical person who is not into computer science and all the AI algorithms, has been beneath the surface until November of last year. So we're actually a couple of weeks ahead of the anniversary. ChatGPT came out on November 30 of 2022. So right now we're not November 30 yet for 2023. So it's actually, everything got really surfaced only less than 1 year, okay? In a couple of weeks, it will be 1 year anniversary when ChatGPT emerged. And that's where everybody started paying attention, because not the experts or the people who are working in this field, but almost everybody have heard about ChatGPT and probably have used ChatGPT. So right now, AI is sort of like everybody's saying, well, what is it, and so on. So given that everybody's focusing on AI, then what we've discovered is that in order to run AI, like ChatGPT, it requires a lot of compute power, okay? And in order to make it faster, is that you need to design specialized chips that are specialized to run the AI algorithms, okay? So biologically, you know, the AI imitates the human brain. The human brain works with neurons, okay? It's basically the neuron sends a signal to the next neuron and so on. So it's via synaptics, okay? So the way that AI works, which is the artificial intelligence or the machine part of it, is try to imitate the human brain, okay? So AI right now mostly is based on the way that neural networks work, because humans use the neurons biologically, and AI or machine learning, it uses ANN, artificial neural networks, okay? So I've given a lot of talks on ANN. I won't be giving too much on that tonight, but let me just say that the way the AI chips, in order for the AI chips to run fast and similar to the human brain, it has to imitate neural networks, okay? So
comes out again. This,
Okay, great. Thank you. Okay, so yes. ChatGPT. Okay. Basically, in November 30 of last year, there's a company called OpenAI. Okay, they came out with a tool, and the tool is called ChatGPT. Why is it chat? Because it's conversational. So it's like I'm chatting with you. Okay, so that's chat. GPT is an acronym for Generative Pre-trained Transformer. Okay, so I won't go into that today, but if after this lecture, if you're more interested in finding out more about that, you're welcome to ask me questions at the end, all right? Okay, so we're saying that in order for the AI chips that, which is the topic for tonight's presentation, is that in order for that to be running fast, is that basically you need to have specialized AI chips that can run similar to the way that the neurons work, okay? So they need to run the algorithms for neural networks very fast and very efficient. So if you do that, then all the computation for AI can run fast enough, all right? So let's start with the first question. What is AI chip? So an AI chip is just a regular chip. There are many chips. There are chips for cars. There's chips for computer vision. There are chips for doing a lot of chores, okay? A lot of all the devices today, probably even your car, your machine at work, at home, they all have chips inside, okay? So tonight we're going to talk about a special set of chips, which is called the AI chips, which are very efficient and very good at doing AI. That's why the definition of an AI chip. Now, how does that differ, say, from a CPU? Before, when we run computer, like remember the days where you buy anything like your PC and it has a thing that says Intel inside. Remember that thing? Well, the Intel inside, most of those were CPUs, a central processing unit. Okay, so that means a computer that runs very fast and it can do many things. It's a central processing unit. Okay, the way that those CPUs work, they work in a serial manner. Serial means one thing, you do it after the next one, it's followed by one thing. And in order for the brain to work, it has to work a little bit different than serial. It's not like one followed by that one, but it's actually things running in parallel. So you can do, it's multitasking, okay? So that's one of the first characteristics about AI chips, is that in order to work, for the AI chip to work like a neuron, it has to work in parallel. Okay, that's one thing. Now, one of the things that we're going to be talking about throughout this evening is that if you're into semiconductors, so let's not talk about AI chips, but chips in general, there are usually three kinds. There are ones, the ASICs, application-specific ICs. There's the GPUs. GPUs are a different kind of processing unit that's good for graphics. That's why it's called G for graphics. So for instance, the way that they got started is that when the kids start playing games, electronic games, they find out that in order to realize the graphics in 3D, they need to have something that runs very fast. Okay, so that's where GPUs came about. And then the FPGAs. FPGAs are more like a variation of a chip that you can program it after the chip is done. Okay, you can change the functionality of it by programming. That's called field programmable gate arrays. All right. Okay, so let's sort of start from the beginning. When the PCs were hot, okay, then everybody says, well, everybody heard about Intel because Intel is the top manufacturers of the CPUs, the central processing units. Okay, later on, when the cell phones become hot, so after the PCs, the cell phone become hot, there's a mobile computing. Okay, and there's a architecture called ARM. ARM stands for Advanced RISC Machines. Okay, so you don't need to, it's just a special kind of machines that's go for mobile communications. Okay, so That's the way it got started. CPUs and ARMs. ARMs is a variation of it. Okay, there's also a company called ARM that basically has a product for the RISC machines. Okay. So as I was saying, then the games came about. The kids start playing electronic games. And in order for them to play games, an very important part is the graphics. The way you display the things that are moving, okay? Things need to be displayed in 3D, okay? And then the graphics has to be realistic, right? So people like it, it's colorful, it's real, it's fast. So guess what? The traditional CPUs are not good at processing graphics because they are good at processing in general. Just CPU means central processing unit. It's just like a computer that can do anything. But when the games came out, they need something specialized in graphics, in displaying 3D stuff. So that's GPUs. So that's, and the first company that started working on GPUs was Nvidia. So the first company that started working in CPUs was Intel, right? Not the first one, but the biggest player was Intel on CPU. For GPU was Nvidia. So right now, with the topic that we're talking about tonight, which is the AI PU or AI processing unit, is that there are several variations of it. So some of them are listed on the last section. They have the DPU. DPU stands for data processing unit. So one of the talks that I've given in the past is that we are now living in the era of data. Data is the new oil. So everything relies on data. Okay, when you go and take your cell phone, you start taking pictures or you capture some image. Well, that's data. When you write the email, you're transmitting text. That's data. So right now, the focus is that in order to have, everybody heard about the term big data. Big data means too much data. You don't know what to do with it. So in order to be able to handle big data, you need to have specialized hardware, such as DPUs, which is a data processing unit, okay? And the NPU stands for neural processing unit. I mentioned that the thing that is mostly focused right now today is called the neurals. So it has to follow the neural algorithms, how the neural networks work. The ANN means artificial neural networks, okay? So a processing unit that specializes in handling neural networks is called a NPU, okay? And now there's another one called TPU. And I'll talk about when we get to the Google, when we talk about tensor processing units. Okay, so T stands for tensor. I'll explain what tensor is later on, okay? But there are so many variants of it. Now you can put everything together and call all of them belong to the category of AIPU. They're all specialized chips that do certain things very well, okay? But they're all enabling AI. So it's called AIPU. So in essence, the topic for tonight's seminar is AIPU, Artificial Intelligence Processing Units. Okay, and then we'll go over the various variations of it. Okay, so we mentioned that when GPUs came about, they do certain things very well. They handle graphics very well. The other thing that's sort of like Jensen Huang and Nvidia luck out is that when they manufacture and develop the GPU, their emphasis was on power processing. And guess what? AI requires the same thing. So they sort of like, it was not like they had AI in mind when they designed the GPU. They were lucky. They say, oh, now the GPU not only does well in graphics, but also is good for AI. So right now they got the lead. So they are leading everybody, but it's not because they were really smart 20 years ago and say, well, I'm going to do the GPU, because at that time their intention was to handle games, okay? But it just happens that games require power processing and so does AI. Okay, so they got the lead on everybody, right? Okay. Now, the thing is that, so they say, well, fine, if you have GPUs, why worry about AI PU? Just use GPU. But remember, the GPU, the initial intent was to handle graphics. So that was not sufficient to handle AI, because AI also requires image processing. Okay. So it requires convolution. So it's not ANN, artificial neural networks, that is parallel, but also convolutional CNN, not the news, not the news station, but convolutional neural networks. Okay, so I'll go over what that is. Okay, so by the time you exit this evening, you'll be hearing a lot of things that maybe you have not heard before. Okay, so so what's a CNN? Convolutional neural networks. Okay, so this is a very important one. Remember that artificial intelligence, one of the subfields of AI is computer vision. Okay, so the AI does many things. It tries to reason, it tries to infer, also it tries to see things. You also be able to handle languages. That's all part of AI. Okay, so one of the things that is very important is, for instance, everybody may have heard about AI to say, well, how does the AI distinguish between a dog and a horse? Okay, let me just give you that question. Well, they all have 4 legs. The dog and the horse, they all have 4 legs. Okay, but their tail looks different. Okay, the legs for a horse are longer than the legs of a dog. So how do you distinguish this feature? And you say, how does the computer recognize that this is a horse and not a dog? Okay, it has to go and filter it out. What are the characteristics of that animal that says this is a dog? The dog, the horse, the tail has many hairs, right? It's not like one single thing. Okay, so without getting into the mathematics, because not everybody here is a PhD in machine learning, okay? But one of the things that in order to do that, for the people who really are more into the computer science, it's all done through matrix, okay? In the mathematics, in the computer science world, the way that you distinguish a feature from another feature is done through matrices. So I just have at the bottom of the page here, 2 matrices, okay? The original matrix that has all the pixels, say, of a picture of a horse. And say, well, how do I know that this is a horse and not a dog? Okay, how do you distinguish between the cat and the dog? And so on, okay? So the way you do it is you do it through convolution. So convolution, I took a lot of math courses when I was working for my PhD, but not everybody here needs to get a PhD in order to know what the AI and the stuff machine learning is. So one of the things that you need to take when I was doing the math is that what's called matrix algebra. Okay, matrix algebra is that multiplying one matrix by another matrix and so on. So in this picture here, do you see at the bottom is that you see thing in the middle? It's a filter that says, oh, a dog has a shorter tail than the horse. And it's a living, looks also different. Okay, so that is captured in a filter. Okay, that characteristic is captured in a filter. So you superimpose the filter matrix on top of the original picture. Okay, and then you multiply the 2 matrices out, and it will tell you, oh, well, this looks like this is a horse tail. It's not a dog tail. Okay, so you do 2 matrix multiplications, and you come out with the 3rd number. So we're not teaching the matrix course here, so you don't need to worry about it. But that's in essence the way that this thing works. If you really want to know, AI is not an easy thing. It's not like everybody can here is getting a PhD in AI, okay? But that's not the intent of tonight's lecture, okay? So basically, I just want to show that in order to do AI and all these AI PUs. There's a lot of math behind it, but it's not required that you also all need to know all the matrix algebra, because everybody in this room know how to drive a car, right? But how many of you can actually fix a car if it's broken? Like if the engine doesn't work, can you get behind the hood or under the hood and fix it? No, right? Not all of us can fix it, but we can all drive the car. We can all use the car. So the same thing with AI. It's not like everybody needs to have a PhD in machine learning in order to use AI. Okay, so that's the reason. The way that you explain that thing is called democratization of AI. That means that AI, everybody can use AI and should be able to use it, but not everybody needs to have a PhD in that field. Okay, just like not everybody is a car mechanic, but everybody can drive a car, right? Okay. So one of the other things about AI is that when we talk about AI is trying to imitate the person. So what are we as humans? We have a head. We have a brain inside the head, right? But we also have arms. We also have legs. We have also a body. Okay, so an AI SoC, system on a chip, there's more than just the brain. So the brain is what people say AI. AI is defined as a very large system. A robot is also AI. But a robot has a head, but it also has an arm. It also has legs. It can move. Okay, so an AI SoC is a system on a chip. It's not just a chip that covers the brain function, but there's also other things. Just like your PC. Your PC, it has a chip that computes all the mathematics and everything, but it also has I/O. You can print the output. You can read the text. So same thing for AI. There's more than just the NPU. The NPU is equivalent to the brain of the human. Okay, but you have a controller that controls the motion. Okay, it also has memory, just like a PC. Your PC has either DRAM or SRAM, right? So similarly for an AI SoC, besides the processing unit, you also have either SRAM or DRAM. Okay, static or dynamic RAM. So I'm not going to get into all of that in tonight's lecture, but there's also input and output. So you input some information and you get something out of it. Okay, and then the other thing that is just like a human body, we have blood vessels and we have nerves. Okay, so that's the interconnect fabric. So besides everything that puts together, the brain, the arms, the legs, all the stuff, your skin, that's called the interconnect fabric. So all of that is part of a system on a chip. So just keep that in mind. So whenever we talk about things, we need to have the big picture. We're not talking only about the brain, but we're talking about AI is imitating a human. It's an artificial intelligence, but also it has everything else. Okay, so back to the brain. The human brain, besides being able to see, we can see with our eyes, we can smell it with our nose, hear with our ears. Okay, so the brain, the AI chip has two main functions. One is called training and what's called inference. Training is like I don't know where you guys have heard or read about LLMs. Have you heard about AI called LLMs, large language models? Because the current way that AI works is like a language. Okay, so in order for a language, like for instance, if you know Chinese or Vietnamese or Spanish, you have to train it, you have to teach it. Okay, so there's one component that trains the machine to learn. Just like when we go to school, we get trained and we learn a new language, or we go and learn math. Okay, so the same thing, an AI chip has to have two functions. One is getting trained, and there's humongous amount of data. Imagine right now, like ChatGPT, it has all the knowledge of Wikipedia. Okay, when we have a question, we go to Wikipedia and we say, okay, tell me a little bit about how to do certain things. Well, ChatGPT has all that knowledge. So how does it know all that stuff? It's because you have machines being trained on that knowledge. Okay, and after you train it, then you go and fetch it. So that's called the inference. Inference meaning, okay, now that you know everything, you go and ask ChatGPT a question, and ChatGPT will answer to you. Okay, so one is the training the brain. The other one is to ask the brain. Okay, so training and inference. Another thing that I don't know how many of you are really computer science people, but either way, you probably have heard about the word cloud. Okay, the cloud. The cloud. Why is the cloud famous? Well, back in the old days, we all used to have our own PC. Okay, and then you find out, well, I need a more powerful PC because it cannot contain all the data that I want, or it does not do computations fast enough. So then to say, well, but how many people have millions of dollars that can spend on any large size computer or with a lot of memory? You cannot do it. So you go to the cloud. The cloud is the central repository, like Amazon, like Google, like Yahoo. They have all your email. Okay, but it not only has your email, it only has his email. So now you're not going to have a computer that handles all the world's people's email. Only the cloud can do it. So the cloud is a very powerful and very large repository of information. So that's why the cloud is. So anything that does not fit on your personal PC, you can offload it to the cloud. Okay, and when you need it, you go and ask the cloud. You say, can you tell me the email that I sent last week to Howard? Okay, you will go and get it. Okay, so that's the cloud. But right now, these days, if you look at the evolution of technology, you no longer can always go to the cloud. Because let's say that you are driving a car. Okay, the car has no driver. We say all the new cars will have no drivers in the future. Well, the car will have computer vision, will know where people are walking around, or there's another car walking, or there's a red light. So, but if you have to wait for your information to go to the cloud and fetch the information, what should I do next? Should I brake? By the time you send the information and you get it back, that's called latency. Latency is the response time. It's not fast enough because by the time you send it, what happens if the network is busy? Your car already ran over the person. So you need to have the computation at the edge. At the edge means right in front of you, real time. Okay, there's no time to send it to the internet and get the information back. So that's called the edge. So right now, more and more, there's a need for both. Whenever you have too much data, you send it to the cloud. But if you need fast response time, you go to the edge. Okay, so those are the two things. So we talk about four things. We talk about the cloud, we talk about edge, we talk about training, and we talk about inference. So yes, do you need to ask it now or can you wait? Because otherwise I'm going to get interrupted all the time. So why don't you write down your question? Because my talk is very long, so I'm not going to be able to go through it if I get interrupted every 5-10 minutes. Okay, so there are four things that we talk about: cloud and edge, training, and inference. Okay, so how do you select the AI chips? You're going to see so many chips today. You have pictures. You will see a lot of pictures today of all the AI chips. Okay, how do you make the selection? It's like when you go to the grocery, you say, what am I buying? The tomato or the lettuce or the cauliflower? Okay, and the meat and the chicken, the fish. Well, you need to go. So by the time you hear my presentation, you have some idea about what to do. Okay, so just to dissect the four things. whenever you need cloud, then you can afford to be slower, but you have to have a larger thing, okay? So in that case, you have to go to a GPU. GPU is a more massive thing, just like the cloud is, okay? But response time is not as fast, okay? When you want to go edge AI, you want to be able to react instantaneously. If the self-driving car sees somebody walking down the sidewalk, you need to brake right away. You cannot say, oh, let me send the message and let me wait for the car to tell me what to do. Okay, so it has different applications, different uses, and different needs. Okay, so you need to distinguish that. Also, whenever you are doing training, so it's different that you teach a person certain knowledge versus when you just query the person. Okay, so because when you are training the person or the machine, it has a lots of data. Just like, for instance, imagine all the information that is contained in Wikipedia. Okay, Wikipedia knows of just about everything. Okay, but we, as a consumer, we don't need to know everything, because do I need to know right now how do I go to the moon and come back, and what's the speed of the rocket and all that stuff? I don't need to know it now. I need to know, okay, how do I drive to, Bill's seminar? Okay, that's it. For tonight, that's all you need, right? But tomorrow, you may need to know a different thing. So training is a very time-consuming effort, and it's a very large effort. Inference is say, okay, right now I need to know only, is it going to rain by the time I get out of this summer? That's the only thing you need to know. So you ask, okay, what's the weather forecast for 8 o'clock tonight? Okay, you don't need to know what's the weather tomorrow. Okay, so inference is much smaller and more efficient. So you need a different thing. So remember I mentioned there's a GPU, there's an ASIC, and there's FPGA. Okay, different devices are good for different things. Okay. Okay, so now let's talk about remember I talked about AIPU, Artificial Intelligence Processor Unit. Okay, there are three main kinds. The GPU, which is the graphics processing unit, the ASICs, application-specific ICs, the field programmable gate arrays, and there's this other thing called wafer chips. Wafer chips just means many chips on one board. Okay, so let's just quickly go over. So GPUs, as I mentioned, the origin of the GPU is when they needed 3D graphics. Okay, be able to display pictures on the PC. Okay, so that's when they came out with. This was in the 1980s, 1990s. So that's like 20, 30 years ago. But they're still good, because all the electronic games that people play, they rely on graphics. Okay, and in order to do that, it requires power processing, which is different than the CPUs. When the CPUs first came out, they're good at just processing tasks, but they were doing one task after the next one. Okay, or they're doing the next one after the previous one. So that's in serial manner. That's the CPU. The GPU, it can do multiple things at the same time. Okay. So GPUs, good for power processing. That's why GPUs are different than CPUs. Okay, and so that's the first one. And as I said, they luck out, because they say when they invented the GPU, they didn't know that they were good also doing something for AI. They just thought they were saying, well, we have a chip that does very well with graphics to do gaming. Okay. So right now, as I mentioned, right now there's another thing called big data. So there's a lot of data. So now you need something specialized that can handle large volumes of data. That's DPU, data processing unit. And they are good for what? Like all the Amazon, Yahoo, Google, they have what they call servers. I don't know where you have heard about the word servers. Servers is just very large computer farms. There are many, many, many computers in one place. That's called a server, what they call a farm. Okay, so there's a lot of data there because imagine all the information that Yahoo has. I can trace a Yahoo email that I sent, say, last year. I may no longer be able to find it on my PC, but if I go and trace it to Yahoo, it probably is in there because they have not erased it. Okay. So, but those information resides only in the data center. They don't need to reside in your PC. As I said, your PC is just your personal information, the thing that you need right now. Okay. The data center is like, I don't know where you guys were old enough to know. Remember, before, if you look at the evolution of computers, the first ones that came out were the large mainframes. That was the IBM mainframe. That was a very large computer that took a whole room. And then they went with the mini computer, which is a smaller version of the computer. And then they went to the PC. And today, everything is just on your cell phone. But anyway, that's a long history to go over tonight. So I won't be doing that. Okay, so DPU. So this is a picture at the bottom. There's a picture of a DPU. It's by Nvidia. Okay. Okay, so without getting too much into this, this is a slide that if you're interested, you can ask me. I'll send you the slide. So like the difference between a CPU, a central processing unit, versus a GPU, which is a graphics processing unit, versus a DPU, which is a data processing unit. So CPUs are good for general computers in general. Like your PC definitely has a CPU. Okay, GPU, if you play games, then you have GPUs. And then DPU is that you have to handle data, a lot of data, then you have a DPU. So one is good for graphics, one is for general task manipulation, and the other one is to handle data very fast. DPUs handle the data back and forth very fast. Okay? Okay, the second category is called ASICs. So when I was working in the semiconductor industry, I used to be ASIC engineer, application-specific IC. It's that you would design a chip depending on what you want the chip to do. Okay, so it's application-specific. That's what AS means. IC is just a chip. So the pros and cons of ASICs. The ASICs are specialized to do a certain function. So they do it, and it's very efficient. So you can run it, and because it's specialized to do only a certain task. So it does it very well. And it does it very fast, very efficient. But the problem is that it's not general. Okay, so if you say, I want to, originally when I designed my ASIC, it's supposed to do certain things, multiply two numbers. And now you're saying, well, now I want to do a different thing. I want to be able to swim underwater. Okay, now you have to change it because it was not original intent. So the good things about ASIC is they're very specialized, so it can do things very, very fast and very efficiently. The bad thing is that it's not general. Okay, so that's in general the neither. So coming FPGAs. FPGAs is in between. It's that you can design an FPGA, and then after the chip is done, the gate array is done, you can change the functionality by programming. Say, oh, originally I want to do that, but now I wanted to do something else. Okay, now you can change it. You can reprogram it. So that's called field programmable gate array. Okay, so it's not as fast and efficient as an ASIC. Okay, it's also not as general as a GPU, but it has flexibility. It can change by programming it. Okay. So I think I'm going to skip this slide here just to show you a few things. So that I'm talking about chips, and you probably never seen the chips. So here, for AI FPGAs, here are two pictures. One is the Intel chip, the AGLX, FPGA. You see actually on the chip itself, it says FPGA. And the other one is the Xilinx. Okay, just to give you some idea about what's the size of the chip. You know, the chip can be actually, when I was working on AI, not AI, but the chips in general, most of the chips, they were the size of your fingernail. That's the size of a fingernail. That's the size of a chip. Now with the functionalities, they're becoming bigger and bigger. Okay, and now you have, oh, I want to do not only that, but I have multiple things. So now you can combine many chips into one module now. Okay, and before it used to be what they call boards. So on a board, you have hundreds of chips, all doing different things. So there are people who are working on PCBs, right? The printed circuit board. Okay, so anyway, but if you look at the picture on the Xilinx, it's actually like a board. You know, there's so many things on there. Okay, okay. So as I mentioned, you start with the basic unit, which is a one chip. And then if you say, well, that's not enough, you know, I cannot put all the functionality on one chip. So then you have multiple chips. And if you have multiple chips, then you put it on a wafer. The wafer is your substrate or your platform, where you put it just like in a board. You can put multiple chips on it. And then you interconnect the chips. Okay. So right now, the AI field is so complicated that already people are talking about wafer chips. Okay, so I'll talk about this company later on. Cerebras is a startup that does AI chips. And because of the functionality, right now it's almost like a mini board where you have multiple chips on it. Okay, so let's change a little bit. So we talk about, you know, what is an AI chip? We talk about AI and stuff. So let's talk about the market. Why are we interested in talking about this subject? Because everybody's getting into this area. Okay. I'll tell you up to the last minute. When I walk in this evening, I had already my slide all prepared. And then they say, well, Bill, have you heard about Microsoft? They just came out with 2 AI chips. And that was today's news, November 15th. I said, no, I have not seen that. Okay, well, anyway, you're lucky because I already included in tonight's presentation. So let's talk about the market first. Why do we need to talk about this subject? It's because everybody says, okay, right now AI is so hot. All the companies like Nvidia, like Intel, Samsung, even TSMC, okay, they all want to say, oh, there's a lot of people, there's a lot of need to want AI chips. Well, they need AI. So in order to do AI, you need to AI chips. So people say, oh, I can make money out of it. So that's the reason why. Everything is driven by money. So I'll talk about the chip market in general. What's the size of the chip market? Why are we into that? And I'll also talk about the major players, all the big companies who are working on AI chips. That's what the next section is about. So first about market size. So this is a 10-year forecast, starting from last year, 2022, up to 2032. So all the numbers that you see here are in billions of dollars. So right now, 2023, the market is about 538 billion. So people say, well, why are we talking about that? Because everybody's interested in making money. They say, well, I don't want to have Nvidia take the whole market. I want to take part of it, right? So AMD is working on it. And people say, well, every time I want to run AI, I need to buy an Nvidia chip. So isn't that too expensive? Why don't I make my own AI chip? So that's where Apple, that's where Microsoft, that's where OpenAI say, I'm going to make my own. Because if I make my own chip, it's going to be much cheaper than if I have to go and buy it from Nvidia. Okay, so anyway, this is the look at the curve, okay, of the market. Now, if you look at the AI chip market, so this study was started in 2022, started last year because the data, only 2023 have data from last year, right? Because today, 2023 is not finished yet. Okay, so we have starting the point was 2022. The market size was 454 billion in 2022. Okay, and then that's going to be $2,575 billion in 10 years. Okay, so the growth is about 5 times at least. Okay, so if you compare AI chips versus semiconductors in general, by the way, I don't know where the sandwich is coming. If anybody's hungry, I think there's supposed to be some light dinner on the back. Okay, so you feel welcome to grab it. So the AI chip market compared to just the chip in general, the chip in general means that multi-purpose chips. You have CPUs, you have chips that do anything. The growth is going to be 5 times larger. That means that basically what I'm saying is that this area is hot compared to the other semiconductor areas. So everybody's focusing on now designing AI chips. That's why the seminar tonight. Okay. So remember in my previous slide, I talked about in the bottom, we had GPUs, ASICs, FPGAs, CPUs, and so on. This is the orange is the market as of last year, 2022. And where it's going in 10 years is the blue. Okay, so you can see everything is growing by 10, 20x. Okay, and that's the reason why everybody's so interested in this topic. Okay. The other thing that compare about is that where are these AI chips going to be used in? So 2 seminars ago, I talked about robotics. Okay, that talk was going on humanoid robots, but anyway. So if you look at the yellow line is the current need for AI chips. And if you look at in 2032, what's the area that's going the most? It's going to be on robotics. Look at it. So that means that most of the chips that the AI chips that people are designing, they're going to be going into robots. They'll also be going into cars, but not as many as in robots. So as a matter of fact, people say Tesla in a few years is not going to be a car company. It's going to be a robot company. Because think about it. There's a much larger need for a robot than for a car. A car, you can go and call Uber and say, okay, I need to go here. Okay. But if you have a robot, the robot can help you do many other things. Can help you with your accounting, to do your taxes, to mow your lawn, to vacuum your house, and all that stuff. So think about it. That's where in all these areas, natural language processing, robotics, computer vision, security, and others, robots in 2032, in 10 years, most of the applications for the chips or uses of the chips are going to be in robotics.
So no automotive.
Yeah.
What?
It's probably in the others. Probably. No, actually cars. Think about it. There's another way to think about it. You can think of a car as a robot. So a car, as a matter of fact, if you look at the vision from Elon Musk, today, everything is cell phone based, right? Everything is inside your cell phone. Okay, camera is in cell phone. Watch is in your cell phone. Weather, information, data is all that. What Elon Musk was trying to do with the EV is he's trying to change the platform from a cell phone to a car. He said, once you go into the car, you can do anything. You can get the news, you can do this, you can do that, you can move, you can do all stuff. So that's another way to interpret it, okay? So you can view the car as a robot also. Okay, so I said that I'm going to cover most of the major players. Okay, let me see how I'm doing in time. I'm doing fine. So here are the list of all the companies. You include US companies like Nvidia, AMD, okay? And then you have a lot of companies who are not into the hardware, okay, like Microsoft, and so on. Okay, they're also getting to AI chips. Okay, and then you have like companies like Apple. Why is everyone getting to AI chips? Because any product in the future will have chips in it. And any product that has chips, the chips most likely are going to be AI chips. That means they're going to be intelligent chips, not just a chip that does certain things. Okay, so whether you are a semiconductor company like TSMC, okay, or Intel, or you are a user of a chip like a Tesla or Apple, they're all going into it. Because if your volume is large enough, why is Apple interested in doing AI chips? Because how many cell phones do you sell? And if you, for every cell phone, you have to use 3 chips. And you have to get all the chips from TSMC or from Nvidia. A lot of your cost is from there. So if you do your own chips, it's going to be much cheaper. That's really the short end of it. So you have Chinese companies, Huawei is there, Baidu is there, Samsung from Korea is there, TSMC. Yes, I'll get into that each of this. Okay, so let's start with the leader, Nvidia. Okay, as I mentioned, Nvidia got into that and it was leader by chance, by luck, because they had the graphics processing unit that was originally down to play in the electronic games, and they decided, wow, we have actually a gold mine now in AI that maybe is even bigger than the games. Okay, so there's a thing. This is also what I personally believe. No matter how smart you are or whatever, how many capital you have, nothing beats luck. You're absolutely right. Nothing beats luck. Okay, so if you are in the right place at the right time, it doesn't matter how much knowledge the other guy or it doesn't matter how smart he is. If you're lucky, you're lucky. Okay, so Nvidia was lucky. Okay, let me just put that. Okay, so everybody heard about 2 chips. The 2 most famous chips right now today is called the 800 and H100. Okay, and I'll go over the difference between the 2. Okay, the other thing that Nvidia is doing is that depending on the end application, they have a different type of chips. Okay, like for example, Xavier. Xavier is for cars, driverless, self-driverless car. It's called Xavier. Volta is good for data centers, the server, the clouds. Okay, and Grace is a new AI chip. So we think Nvidia, look at the number of products that they have. They have a lot of different products depending on their end application. Okay, so just to show you, so that you're talking about look a lot of text. So I'm in AI, so I'm going to show you some images. So one is the Grace super chip. So this is what the chip looks like. So for people who are not into semiconductors, or what's the chip? You know, how does the chip look like? Okay, and this is the A100. So right now, currently today, the most 2 famous chips are the A100 and the H100. Okay, I'll explain what the difference between the A and the H. I don't have it. I may have it in one of the slides, but you can find it out. So somewhere in there is somewhere in that upper right corner, there's the size of the die size. Okay, so here's the size of the chip, H100 and the A100. So by the way, just to spell out, why is one called H100? The GPU, any IC, it depends on the architecture. Okay, the way that, what is the intent use of it? So the H100 is based on Hopper, H for Hopper, and A is for Ampere. Okay, I'm not going to, the story is very long, so I'm not going to go through the whole story why it's called Hopper. Hopper is actually the name of an engineer called Grace Hopper. Okay, Ampere, I don't know where that, it has another long story. Okay, but anyway, so when you hear about H100, it's Hopper architecture, and A100 is called Ampere architecture. Now, each of them, why are there so many variations? Because I said, depending on what the intention of the chip is. Okay. So if we're talking about AI, the A100 is better for AI use, for machine learning, for training. Okay. The A100 is better. Okay. The H100 is more for gaming. Remember that originally the GPU started for gaming. Okay. So it has, you know, if you want, I can send you this stuff, or you can just Google it yourself. But here's a side-by-side comparison. Okay, the A100, by the way, is more expensive than the H100. H100, however, is actually newer. So there are too many ways to compare it. Okay, so you have to read the whole spec of why is this faster than the R1? Why is this one more expensive than the R1? It's because the configuration or the architecture of each of the chips is different. Some of them have more memory. Some have less memory. Some of them is faster in terms of the performance. So it depends on the intent. Okay. So here are a couple more notes. A100 is for high performance computing. Okay. And also it's good for training. Okay, so that's why it's good for AIs. The A100 is a little bit better. Okay, H100 is actually more for good for other things, like data intensive stuff, climate modeling, gaming. H100 is a little bit better. Okay, so all of that stuff, I don't think you need to go and remember everything, because you can always go and find it. You know, go and Google it or Yahoo it, and you say, as the way I compile all the slides and say, tell me the difference between 800 and H100. And it gives you all that stuff. Of course, you have to read it and digest it, okay? Okay, so just to show you how fresh my material is, okay? This is a slide that I got it Monday of this week. So today we're 15. This one came out on November 13th. We're no longer talking about H100. We're talking about H200. So this is H200, released on November 13th of this year. So just this week. And then I'm going to show you one more news that I'm going to get, just the latest news from today. So you're going to see that every day there's something new. Okay. So, by the way, when we're talking about, just to go back to the one thing that I always like to do is to put this chart here. This is scientific notation. That's the powers of 10. So when we are buying our PC, we say, well, how many gigabytes of memory? How many, how fast is it? How many gigaflops or megaflops? Okay, there's all scientific notation. So mega is 10 raised to the power of 6. That's 1 million mega, 10 to the 6. So this one, it says it does 4 petaflops. What's a petaflops? Just for your reference. A petaflops is 10 to the 15. So compare that 10 to the 15 compared to 10 to the 6. It's three times much faster.
So here, you think it's 2 chips there or what? You have 2 separate.
I think this is just one. I don't know why it has 2. It's almost like, remember in the CAD days, we have dual screen. When we're doing the layout, you're seeing this on the schematic on that. So I don't know why they look like 2 chips, but this is just one. This is the H200. So this is not like 2 chips. It's a 1 chip that looks like that. And don't ask me why, because I didn't design it. Okay? Yes, they are. Of course, they are on the same substrate. Whenever you see 2 things on the same thing, is that even if you don't see it, they are all connected behind on the substrate. On the where you put the things, they are connected. Okay. Don't ask me. That's a separate for a seminar in 2024. So if you want to know, come next year. I can. I mean, it's nothing new. I mean, tonight I can go and find out, but but so can you. You can go and find out too. But do you need somebody to explain it to you? So that's the difference. I mean, we live in a day of big data. Everything that you want to know, you can find it. But when you get the trick is the following: when you get the information back, do you understand it? That's the trick. Okay, people always ask me to say, well, if you know, say, a different language, let's say French, okay, because I know enough French to be dangerous, but although I cannot do a conversation, I'm fluent in Chinese, English, and Spanish. Okay, French, I had 5 years of French, but I cannot talk to a person in French. So the thing about the thing is that it's not how much you know. For instance, okay, you say, oh, I know French, I can go to Paris and ask for a hamburger, or say, tell me where's the Louvre. That's not the trick. The trick is not where you know how to ask the question. It's that when they give you an answer, how you understand it. So let's say you say, oh, how do you get to a Louvre? Well, I say, well, first you have to go and take the bullet train, and then you have to get off this station, and then you walk 3 blocks. Well, can you understand the response? It's not like where you can ask the question. That's not the trick. The trick is that can you understand the answer? So the same thing. You can Google anything. You can find out anything. You're going to say, oh, what's the speed of the H200? I tell you, well, it's in whatever megaflops is whatever. But do you know what's a megaflop? Or do you know what's the speed? Do you have the scientific background to understand? Oh, that means it's this fast. Okay, so that's the trick. Okay, enough on this one. Okay, so that's Nvidia. So I'm going to go and talk just quickly about different companies. All the big players are going to be here. This is AMD. AMD, by the way, you know that after Jensen Huang made all his trips to Taiwan and so on, so did Lisa Su. I said, oh, well, AMD is not going to fall behind Nvidia. We're also going to get into the market, right? So they're not going to be competing, right? So AMD has also the AI chip called the MI300. Okay, so this is what it looks like. Don't ask me why. It's almost like saying, well, a kid asked me, well, why do I look like this? Well, your parents look like that. I mean, don't ask me why, your genes. I don't know. Okay, Intel. Intel was the leader of CPUs. Okay, every PC has an Intel chip, central processing unit. It may not be good to do graphics, but it can do all the things that you want, right? That's called CPU. So Intel is also getting into it. So look at it. It says, remember that I mentioned training? Okay, they have different names, product names for different things. Now, in order to do training, remember the training and the inference? Okay, in order to do the training, they have the Gaudi. Okay, and then they have the Goya. Well, it just happens that I know enough about art. I say I know who Goya is and what Gaudi is, but not everybody knows it. Well, but you can always Google it, or you can ask ChatGPT. Okay, and then there's the NCS2, neural computer stick. So this one means probably it has more than one thing inside. So it depends where you're talking about single chip or talking about system. If it's a system, it can put together many things in there. You can put memory, you can do the processing unit, the NPU or whatever, the GPU, and then it has coupled with it, it has memory. And it has all the interconnection between the two. So because everything that you need, the main thing is the data. The data is like the blood in your body. You have the brain, you have the arms, you have the head, you have the foot, right? But what makes it work all together is the blood and the nerves. By the way, I teach philosophy too, so that's why I can talk about. Okay, so TPUs, this is a thing called tensor processing unit. So by the way, where are you going to get a lecture that covers everything, like I covered today? NPUs, TPU, DPU, CPU, GPU. Okay, right. So people used to call me, Bill, you are actually like a walking ChatGPT. But before ChatGPT came out, people refer to me and say, Bill is a walking Wikipedia. It's a person can walk, but with the knowledge. Okay, so what's a TPU? So let me explain what the tensor is. And this is for people who do not know enough about matrices. Okay, a tensor is an n-dimensional. So what's a dimension? We live in a three-dimensional world. Okay, this table, well, the surface is two-dimensional. That's the length and width. But if you look at it, take on account the legs, it's a three-dimensional thing. So, and then you can extrapolate. Okay, so if you have only one length, it's one-dimensional. If you have two, length and width is two-dimensional. If you have length, width, and height, it's three-dimensional. And you can extrapolate to any number of dimensions. People say, maybe we only see three-dimensional, but there's only somebody walking around us, but we don't see, because we only see three dimensions. Okay, so back to tensor. A tensor is a n by n. N is, it can be greater than 3. Okay, now if you do a scalar, so I mentioned some also for people who know enough about math, a scalar is called rank 0. Okay, a vector is called rank 1. Rank 1 means that you have like a column. A scalar is just one number. Scalar is one number, 0 dimension. Vector is a column or a row. Okay, that's a vector. And then you have a matrix. A matrix is a m by n. It's a two-dimensional. You have number of rows multiplied by the number of columns. Okay, and then a tensor is even above that. It can be n by n or m by n. So just this is the abstract concept so that you know what the tensor is. Okay, but you don't need to take the PhD qualifying to know about that. Okay, so a tensor is n-dimensional. Okay, so I'm just giving you an example that you can understand, which is like two-dimensional, you know, and one dimension is only one surface, right? So the Google also have a couple of chips, AI chips, and their name of the chip, they're named after, remember, is a cloud and edge. Okay, so they say this chip is good for cloud applications. So it is, oh, I need something that has very large data and all that stuff. So I need a cloud AI, cloud TPU. TPU is a tensor processing unit. So when you're going shopping and you're buying a Google product, you know what it's called. So everything in my slides that has a bold face is the name of the chip. Cloud TPU, edge TPU. Okay, and just so that you know what the chip more or less like. All these are the pictures from Google. So depending on which company I'm showing that's what it looks like. Okay. So it's not only the companies that do semiconductors like Nvidia, AMD, and so on. Everybody heard about IBM. Okay, IBM also has its own AI chips. IBM even has their own quantum computer, right? Yeah, so anyway, so IBM's AI chip is called North Pole. Okay. And, you know, this is what it looks like. Again, you know, it has the name North Pole in it, but it actually looks like a board to me, but I don't know. This is the picture of the chip. So this is not just like one chip embedded on the thing, but this is, whenever I go, you Google IBM North Pole, and then you type in image, this will come out. This is the picture of the IBM chip. Yeah. Well, aren't you glad you get the 2 for the price of 1? Okay, so Samsung. Okay, so this looks like a single chip, right? Samsung is called Exynos or Exynos. I don't know how to pronounce it. Okay, so Samsung has their own. So as I mentioned, there's another company that is not interested in AI chips, because if you have a product, you have going to have an AI chip inside your product. And in order to make it cost effective, if you do it yourself, it's gonna be cheaper.
This may be edge, yeah, not a cloud.
Right, right, could be. You're right. It doesn't look like
Otherwise,
a
they
cloud.
think-
Right, right. By the way that the cloud
AI.
things work, you know that a farm like Amazon or Walmart, they have farms
Mhm.
with servers, right? Google, Walmart, Amazon. Their farm is made up of thousands of these chips. So what they mean is that they have a data center. A data center has all the hardware. They have racks and racks of chips. It's just they used to be that. So why Nvidia is making so much money? When they don't buy like one chip at a time. They buy, oh, I need a data center, so I need about 3,500 of those chips. You know how much each of the chips cost? $4,000 or $5,000 each. So easily can run into it. That's the reason people say, well, I'm not sure I can afford to spend so much money on Nvidia. So I better make my own. Okay, so that's the short story about why everybody's concerned. Okay, so a couple of startups. So I mentioned that everybody's trying to get some money out of it. So the big companies like AMD, Nvidia, Samsung, they're all trying to make it the big buck because they sell it in very large volumes. There are also new startups. For any new technology, there's going to be some startups. Okay, so this is the Samba Nova. Okay, so they also go and get some round of funding, $676 million. So their chips are also supposed to do training and inference. Remember that I gave you the background about why do we need to have training and why do we need inference? Okay. Remember the wafer chip? This is the way that this thing looks like. It almost looks like it almost looks like a wafer. A wafer is where when we did the chips, is that you make it in wafers and then you slice them into the chips, right? So this one is almost like the whole wafer.
How much money they raise?
Huh?
$1 billion.
Yeah, I don't know. I was not one of the founders, unfortunately. I'll be able to tell you.
How do you interface the wafer with the prompt?
Well, the answer is actually very simple.
Not the
The question is that, okay, today you heard about PCBs, right? You have a one board, you have hundreds of chips on the board. And then you slice the board inside the rack. And then that board is interfacing with the other boards on the system.
It's not USB.
So everything is connected, but there's no one unique answer that I can give you because when I give you one answer, there's other application that does it differently. But think about it. If you're mounting this type of thing, like a wafer inside the system, you have other connectors. It has also cables. It has other things. So how does it interplay? That's the way. No different than, okay, if you open up your refrigerator, there's a chip, and then the chip is connected to the LED lights and all that stuff. How does it work? It's just all the electronics.
The wafer scale, their only customer is just a bigger other farmers, not a small company. No. I mean, the Cerebras.
You mean like, so it depends. So remember, just like, for instance, if you look at, let's just talk about a car because everybody knows about a car. A car has tires, a car has gasoline, a car has mats, a car has brakes, okay? You may be manufacturing only one component of the car, okay? But then also car companies that sell you the whole thing. The car already ready, already assembled with a mat, with a mat on under your feet, and also with the engine and all the AC and the GPS. Okay, or you can just buy a single component. So, well, how does the GPS fit inside your car? How is that connected with it? It depends. It depends where you're buying the whole package already assembled for you, or just buying one thing. Remember back in the old days, Howard, is that when I first we were into stereo systems, how did we used to do it? We would buy the best of everything. We would buy the best set of speakers. We'll buy the best amplifier, we'll buy the best tuner, the best turntable, and then we'll put it together ourselves, right? But you can also buy a system that is already assembled for you. So, okay, so just, I'm not going to go every single company, but Huawei, so China is also doing the same thing. Huawei also has the thing, their call is called ASICs 910. Yeah, it really looks pretty. Yeah. Okay, so Huawei is called ASICs 910. Okay, Alibaba and Baidu. So Alibaba is actually not a chip company or a AI company, but they have to use the thing. So they see this is the Hangguang. Hangguang is the chips that they use. Baidu just buys it from Huawei. Okay, they asked me to quickly wrap up, which I can do very fast. Okay, so everybody heard about OpenAI. Remember the question originally asked, ChatGPT? Well, this is the company that released the ChatGPT. So what does the CEO say? We're paying so much money to Microsoft in order to run their server. And then Microsoft is saying, I'm paying so much money to Nvidia because I'm using all the Nvidia chips. So everybody says, well, let me just do my own, because if I do my own, it's going to be much cheaper than buying from outside. So they're considering either to do their own AI chips or buying a company. Okay, Apple also, all the cell phone has chips in there. So they have A11, A12, A13. So it looks pretty simple. I like it. You know, I like everything simple. A13.
Tesla.
Huh?
Tesla.
Tesla, of course.
Is it like the
Yeah.
chips?
You know, do you know that the way that Elon Musk envisioned Tesla,
Yeah.
they envisioned their EV, like their, Model S and Model whatever, 300, whatever. They envisioned that's like computer. Because think about it, their car actually has a computer in it. Right? Their software is actually AI software.
But
So-
right now, the chip from Nvidia.
I don't know right now. Right now, probably, but I will bet that they're doing their own. For example, let me show in my last talk when I talk about robots.